Welcome to The Explainer. You know, for the longest time, we've all been told that in AI, bigger is always better. But today, we're diving into this fascinating paper from NVIDIA Research that basically flips that idea on its head. It argues that for the AI that actually does stuff for us, the future is small.
Yeah, for years, the whole story in AI has been pretty simple, right? Bigger is better. We've all seen the headlines about these massive large language models, or LLMs, and they're all built on this one assumption. You pile in more data, you add more parameters, you get more power.
But here's where this new paper from NVIDIA Research comes in and throws a wrench in the works. They make this really bold claim. They're saying that for AI agents, the systems that are supposed to actually do things for us, like booking a flight or managing our software, that whole bigger is better idea, it's not just inefficient. The authors are arguing it's fundamentally wrong. And trust me, they do not mince words. This quote right here, it basically lays out their entire argument. It's a total reversal of the way most people think about AI right now. They're stating, arguing, and defending the position that small, not large, language models are the future of agentic AI. So how do they back this up? Well, the researchers build their entire case on three core ideas. You can think of these as the three pillars holding up their whole theory. First, they argue these smaller models are already plenty powerful enough for the job. Second, they're more suitable, meaning their whole structure is just a better fit for how these AI agents actually work. And third, and this is a big one, they're way more economical. We're talking vastly cheaper and more efficient. Let's break each of these down.
All right, let's dive into that second pillar, the idea that smaller models are a better fit. To really get why they're saying this, we first have to take a look under the hood at how these AI agents are actually put together.
Okay, and this diagram from the paper itself, this explains it all perfectly. It shows the two competing ways to build an agent. Now, look at the one on the left. That's the monolithic approach. Think of it like a single, brilliant, but totally overwhelmed genius who's trying to do everything at once. It has to understand what you want, figure out the right tools to use, call those tools, process the results, all inside one massive brain. It's a lot to handle. But now, look at the design on the right. This is the modular, LLM-friendly system. And it's completely different. It works less like a single genius and more like a really good project manager. That's the controller, who's directing a whole team of specialists. So when a request comes in, the controller doesn't try to do the work itself. Nope. It just figures out who the best expert for the job is and delegates. And that expert could be a software tool, or it could be a small, highly trained language model that's an absolute pro at one specific thing.
And when you break down the workflow, the difference becomes, well, it's just crystal clear. With that monolithic model on the left, that single big LLM is the single point of failure. If it messes up just one part of a complicated task, the whole thing can just fall apart. But in the modular world on the right, you've got this robust team of specialists. That means the whole system is stronger, it's way easier to fix if something goes wrong, and ultimately, it's just so much more efficient and can scale up much better.
Okay, so that modular theory sounds great, right? It's elegant, but here's the real question. Does it actually hold up in the real world? Can these smaller models actually deliver the kind of performance we need? Well, the evidence is surprisingly, and I mean really surprisingly, compelling. I mean, just look at the proof that's been coming out of top research labs lately. It's wild. We're seeing these small language models, SLMs, that are consistently punching way above their weight class. You've got Microsoft's Phi 2 model. It has the reasoning skills of models that are 10 times its size. And check this out. Salesforce created an SLM that is actually better at calling software tools than GPT-4o, which is one of the most powerful frontier models on the planet. DeepMind's Retro is another jaw-dropper. It matches the performance of the giant GPT-3, but with 25 times fewer parameters. This isn't just a fluke, you guys. This is a real, powerful trend. And then we get to the money, the economic argument. And honestly, the numbers here are just staggering. We're not talking about little, tiny efficiency gains. For the exact same task, a specialized SLM can be anywhere from 10 to 30 times cheaper to run than a massive general-purpose LLM. And that's a direct line to huge savings on compute costs, on energy, and on how fast you get a response. And if we visualize this, look at this chart. This is performance on a really key agent skill called tool calling, basically how good the AI is at using a piece of software correctly. The story here is just undeniable. That first bar, a specialized SLM, isn't just competing with the giant frontier model, it's actually beating it. This is some of the strongest evidence you can get that for these structured, often repetitive tasks that agents do, specialized training just wins. It beats raw generalized power hands down. Okay, so the obvious question here is, if SLMs are so amazing, why aren't they everywhere already? And that's a totally fair question. The paper actually sees this coming and tackles the main counterarguments head on. All right, so the biggest pushback you hear is the generalist argument. The idea is that an LLM's huge pool of general knowledge, what some people call its semantic hub, will always give it an advantage. But the paper's rebuttal to this is, I think, really powerful. They say that this whole line of thinking misses the entire point of how modern agent systems are designed to work. Good agent systems are all about breaking down huge, complex problems into simple, little, well-defined subtasks. And for those simple tasks, the gigantic overhead and cost of a generalist model is it's pure overkill, especially when you can take a small model and cheaply fine-tune it to become a world-class expert on that one specific job. So where do we go from here? What's next? Well, the researchers don't just, state their opinion and walk away. They provide a practical roadmap for the entire industry to actually start doing this. They literally lay out a 6-step playbook for converting from LLMs to SLMs. It's basically a recipe that any company can follow. You start by logging your data, you identify those repetitive tasks that your expensive LLMs are handling right now, and then you fine-tune these cheap, efficient SLM specialists to take over. It's a really practical guide for making this whole shift happen. And this right here, this quote, gets to the absolute core of their conclusion. The shift to SLMs isn't just about a technical preference. The authors argue that the incredible savings in both cost and energy will act as a powerful catalyst. What they're saying is that economic pressure and the need for sustainability will naturally push the entire industry in this direction. In their view, this isn't just a nice-to-have. It's an inevitable evolution, and it's driven by the very real, practical need for AI that is both scalable and sustainable. So when you boil it all down, this paper is way more than just a technical document. It's really a call to action. It's an invitation from the researchers to the entire community, to developers, to other researchers, to business leaders, to jump into this conversation, to challenge these ideas, and to help build this vision for a smarter, more sustainable AI future. This is a conversation about the future of how we build intelligent systems, and it's happening right now. And hey, if you want to stay on the cutting edge of conversations just like this one, and you want to really understand the huge ideas that are shaping our world, make sure you hit that subscribe button and join us here at The Explainer. We're here to break down these game-changing breakthroughs so you're always ahead of the curve. Thanks for tuning in.